Alright, let's talk about the slope. The slope is also called the rate of change of a linear equation. And the way that you can find it is that you're just going to find the change in y over change in x. That's what this triangle means. That triangle is called delta, and this is saying delta y over delta x, or change in y over change in x. And the formula for it is just y2 minus y1 over x2 minus x1. So change in y over change in x. So let's look at how we can find the slope for a line. What you're going to do is first just find any 2 points on that line. Let's say I take this point here and this point here. This point is 2 comma 7, and this one is 1 comma 5. So let's say that this point here is my x2 comma y2, and this point here is my x1 comma y1. It doesn't matter which one is x2 y2 and which one is x1 y1. You just have to pick one coordinate to be one of these. So now what we can do is, applying the formula change in y over change in x, we can see my y2 minus y1 is going to be 7 minus 5, and my x2 minus x1 is going to be 2 minus 1. So then my slope is going to be 2 over 1. And what this means is that for every 2 unit increase in y, x increases by 1 unit. Or sorry, I read that wrong. For every 1 unit increase in x, y increases by 2 units, right? We always want to talk in terms of the independent variable. So for every 1 unit increase in x, y increases by 2 units. And we can see on the graph that makes sense, because let's say we take this point here, right? If we increase x by 1 unit, we can see that we have to increase y by 2 units to get back to the line, right? And same thing, if we increase x by 1 unit over here, we have to increase y by 2 units to get back to the line. And the slope of a line is always going to be constant. It's always going to be the same. The slope also works in the opposite direction. So we said that for every 1 unit increase in x, y increases by 2 units. Well, if I make both of these negative, it still works. Remember that negative 2 over negative 1 is the same thing as positive 2 over positive 1, right? Because the negatives cancel out. So this is like saying 1 unit decrease in x, y decreases by 2. So let's look at what that means. Let's say we start at this point and I decrease x by 1 unit. So I go backward by 1 unit. Then we can see that we have to decrease y by 2 units to get back to the graph. If I decrease x by 1 unit, we decrease y by 2 units to get back to the graph. Let's talk about, now that we know how to find the slope, let's talk about how we can actually write the equation for a line. One of the most common ways to write an equation for a line is using slope-intercept form, which is y equals mx plus b. So this is what slope-intercept form is. Obviously the y, that's just representing your output. X represents your input, right? But then there are these m and b variables, right? M is going to be your slope, and b is going to be your y-intercept. Now, we just calculated the slope as, let me erase these for now. We calculated the slope as 2 over 1, which is equal to 2, right? So I can plug that in, y equals 2x plus b, right? So I'm actually really close to finding my slope, my equation for the line. The only thing I'm missing is this b, right? The b value represents the y-intercept. The y-intercept is just the y value when x equals 0. So if I go back to my graph, let me erase this for now. I want to find the y value when x equals 0. Well, x equals 0 over here, right? So if I go up and, where's the graph at when x equals 0? At this point, right? 0, 3. So I can see that when x equals 0, y is equal to 3. So then 3 must be my y-intercept. And now I can plug that in for b, and I get the full equation representing my line. Also, one important thing to note about the y-intercept is that it's sort of the, like in the context of word problems, and we'll see how this comes into play later, but in the context of word problems, the y-intercept represents sort of the initial or starting value when x equals 0. Let's look at this graph and see if we can find the slope, the y-intercept, and the equation. So again, I'm just going to pick any 2 points. Let's say I pick this point and this point. This one is negative 4, 6. And this one is negative 1, 4. And once again, I'll take this as my x2, y2, and this one as my x1, y1. I'll do y2 minus y1, which is 6 minus 4, over x2 minus x1, which is negative 4 minus negative 1, which is equal to 2 over, let's see, 2 over negative 3, right? Or, negative 2/3, right? Now, we can see that the slope is negative, right? And what that means is that our graph is going to be sloping downward, right? It's going to be decreasing from left to right, which we can see that is the case, right? Now let's take a look at, what is the interpretation of the slope? Well, this could either mean two things. So I know that, right now I've written it as 2 over negative 3, but the actual slope is negative 2 over 3, right? Which could mean 2 over negative 3 like I've written, or it could also mean negative 2 over 3, right? Both of these are equivalent to negative 2 over 3. So, which one is it? Well, it's either one, depending on which way you want to interpret it, right? This slope says that for every 3 units that x decreases, y increases by 2 units. Let's look at what that means. Let's say I start at this point and I decrease x by 3 units. So I go backward by 3 units. Well, then y must increase by 2 units, right? Because y is positive 2. That's what that means. This one says for every 3 units that x increases, right? Because we have positive 3 on the denominator. So remember that it's change in y over change in x, right? So this one is saying that for every 3 units that x increases, y decreases by 2 units. Let's look at what that means. So for every 3 units, let's say I start at this point and I increase x by 3 units, so I go 3 units to the right. Y must decrease by 2 to get back to the graph, right? And we can see that that also works. So again, both of these slopes, both of these interpretations would work. But, in our equation, we can just write negative 2 over 3 as our slope. So we have our slope or our m value. Now let's talk about the b value or the y-intercept. So we can see, looking at my graph, x equals 0 over here, right? So if I go here at this, x equals 0, and I see where is the graph at when x equals 0, we can see that it's right here, right? I'll estimate that to be about 3.2. So now what I can say is that, this point here is 0, 3.2. So when x equals 0, y is equal to 3.2. And now, I can write my equation y equals mx plus b. I can plug in, let's see, m value or slope we said is negative 2/3. So y equals negative 2/3 x plus 3.2, right? Because that's my y-intercept. All right, and then that's my equation for my line. Okay. We're gonna do one final one for finding the equation of a line. Let's do this one real quick. Let's say I take this point and this point. So we can see that this point here is 4, 7, and this one here is 5, 8. So again, if I plug this into my equation for my slope, I get change in y over change in x over, change in y over change in x, which is 8 minus 7 over 5 minus 4, which is just 1 over 1 or 1. So in other words, for every 1 unit that x increases, y increases by 1 unit, and for every 1 unit that x decreases, y decreases by 1 unit. And we can see that that is the case, right? Because if we increase x by 1 unit, we have to increase y by 1 unit to get back to the graph. And also if we decrease x by 1 unit, we have to decrease y by 1 unit. So that works, that checks out. Now let's find our y-intercept. We can see that our y-intercept, our y-intercept when x equals 0 is at this point 0, 3, right? When x equals 0, y is equal to 3. So again, I plug those into my equation, y equals mx plus b. My slope is going to be 1 and my y-intercept is going to be 3, so I get y equals 1x plus 3, or just y equals x plus 3. That's the equation representing my graph. One more thing I want to say is that, if you have the equation for a graph, that means that you can find the y value for any given x value. So let's say I didn't, I don't want to look at the graph, but I want to find the y value when x is equal to 6, let's say, right? Well, all I need to do is plug in x equals 6, right? And when I do that, I get that y is equal to 6 plus 3, or 9, right? And if I go back to my graph and confirm, when x equals 6, y does indeed equal 9, right? Right here at 6 comma 9, right? So that's, one use that you can have for an equation. Okay, so now we're going to talk about the different types of equations. These are just different ways that you can represent and model a graph and different things that you might see on the SAT. So let's start off with slope-intercept form, which is the one that we just used. It's one of the most common ones. Y equals mx plus b. Again, y is your output, x is your input, and then m is your slope, and b is your y-intercept. Again, we, just went over that. It's the equation that we've been using. So for example, if you have y equals 4x minus 1, then your slope is going to be your x coefficient, or 4, and your y-intercept is this constant value, or -1. And it's also important to be able to identify the slope and the y-intercept from different types of equations on the SAT. Just like, word problems, you might be asked to identify them. Okay, now let's talk about point slope form. So for slope intercept form, we needed to know the slope in the y-intercept. For point slope form, you need to know the slope still, and you also need to know a point on the graph. So you don't actually need to know the y-intercept, but you do need to know any point that lies on the graph, right? And once you have that point, you can write the equation y minus y1 equals m times x minus x1, where x1 comma y1 is going to be any point on your line, right? And obviously m is your slope and x and y are your input and output. So, one more thing I want to say about this is that don't get confused on these, because notice how it's x minus x1, right? That means that if I had x minus 4, my x1 value would be 4, not -4, because in the equation it's x minus x1, so you want to take the opposite of whatever sign is in here with your x. So if it's -4, then your x1 value is +4, and if it was like x plus 4, then your x1 value would be -4. All right, so just keep that in mind. And the same thing goes for y minus y1. If your y1 value, if it's like y minus 3, then your y1 value is going to be +3. All right, so just keep that in mind. And we can look at an example equation like this. For this equation that's written in point slope form, our slope is going to be 4, and my point on the line is going to be 2 comma 7, right? I get my x1 value from here, the opposite of this value, and my y1 value from here, the opposite of this value, so that gives me 2 comma 7. All right, lastly, we have standard form, which is ax plus by equals c, where y is your output and x is your input. So the way that this works is, the special thing about standard form is I don't think it comes up too much on the SAT, although it does come up sometimes. But the special thing about this is that it makes it pretty easy to find your x and y-intercepts. We know that the y-intercept is just the y value when x equals 0, right? And the x-intercept is just the x value when y is equal to 0, right? So what I can do, if I have this equation, 3x plus 4y equals 12. Let's say I wanted to find the y-intercept. Well, I just plug in x equals 0, and then this entire term becomes 0, right? 3 times 0 is 0. So 3 times 0 plus 4y equals 12. Basically 4y equals 12 and y equals 3, right? Same thing, if I wanted to find my x-intercept, or the x value when y equals 0, I just plug in y equals 0. I get 3x plus 4 times 0 equals 12. Again, this becomes 0. And then 3x equals 12. Divide both sides by 3. X equals 4. So standard form makes it pretty easy to find your x and y-intercepts. Okay. Let's look at some examples on how we can find the different types of equations for a graph, right? So let's say that we have this graph, and we're already told that our slope is 3 and our y-intercept is 5. We want to write the equations and graph. Okay, so we're given the slope and y-intercept off the bat, so we can immediately write this in slope form, right? Y equals mx plus b. Remember, m is our slope and b is our y-intercept. We know that our slope is 3 and our y-intercept is 5. So I can just plug in those values. Y equals 3x plus 5, and that's my slope-intercept form. Now let's talk about point slope form, or y minus y1 equals m times x minus x1. So we have our slope, and the only other thing we need for point slope form is x1 and y1. So what I can do to find x1 and y1 is I can just pick any point on my graph, right? So let's say that I take, I don't know, this point for example, right? This point right here, we can see that this point is -1, 2. So why don't I just use that for my x1, y1? If I plug that in, y minus y1. Well, what is, let me write down my point first, right? -1, 2, right? So if I have y minus y1, well, I know that my y1 is equal to 2, right? So y minus y1 becomes y minus 2 equals m times x minus x1. Well, I know from, this part up here that my slope is equal to 3, so I can say y minus 2 is equal to 3 times x minus x1. Well, x1 is equal to -1, right? So if I had x minus x1, that's x minus -1, right? And x minus x1 actually just becomes x plus 1, right? So that's my equation in point slope form. Now, how do I write my equation in standard form? ax plus by equals c. Well, the easiest way to write it in standard form is to start with slope-intercept form and just solve this so that it looks like this, right? Or rearrange this equation so that it's written in this form, right? Because we know that this equation already represents a graph, right? So what I want to do is I want to move all my x and y variables to one side, right? So I'm going to start off with my slope-intercept form, and I'm going to subtract both sides by 3x, and I end up getting negative 3x plus y is equal to 5, right? So I can see that my a value is going to be -3, so ax, and then my b value is going to be just 1, right? Sorry, -3x plus 1y is equal to 5, right? So my a value is -3, my b value is 1, and my c value is 5. So that's how I could write this equation in standard form. Okay, let's look at this one. This one, we're given the slope-intercept form, and we want to write the equation in other forms and graph it. So let's start off by graphing this. If we have this equation in slope-intercept form, I know that my slope is -1/2 and my y-intercept is 4. So when you're given an equation in slope-intercept form, the easiest way that you can graph it is start off with your y-intercept. We know that the y value when x equals 0 is 4, right? So when x equals 0, y equals 4. So we immediately have a point, right? 0, 4. So I'll plot the point 0, 4, and that will be my starting point. Now I can see that my slope is -1/2. -1/2 is either -1 over +2 or 1 over -2, right? So I can either say that for every 2 units that x increases, y decreases by 1 unit, or for every 2 units that x decreases, y increases by 1 unit. So for every 2 units that x increases, y increases by 1 unit, so that's another point. For every 2 units that x increases, y increases by 1 unit, that's another point, right? I can also say that for every 2 units that x decreases, or sorry, I've been writing that a little bit wrong. For every 2 units that x increases, y decreases by 1 unit. So for every 2 units that x increases, y decreases by 1 unit. This is the correct form. For every 2 units that x increases, y decreases by 1 unit. Okay, so these are, that's one way that I can get some points. The other way is that I can say that for every 2 units that x decreases, y increases by 1 unit. So if I go backward, if I decrease x by 2 units, then y increases by 1 unit. If I decrease x by 2 units, then y increases by 1 unit. And these are some more points, right? Now that I have a couple points, I can just connect these and draw a line. And it'll look something like that. It's not a perfect line, but that's the general form, and it'll go on forever in both directions. Okay, now we want to write this equation in other forms. So let's start off with point slope form. We have y minus y1 equals m times x minus x1. Okay, well, I already have my slope is -1/2. Now I can just pick any point on the graph for my point, right? I can take, let's take this point, 2 comma 3, right? So 2 comma 3 will be my, sorry, 2 comma 3 will be my x1, y1. So okay, so if I plug that in, I get y minus 3, right? My y1 value is 3, so y minus 3 equals -1/2, that's my slope, x minus x1. Well, x1 is 2, right? So -1/2 times x minus 2, that's going to be my equation in point slope form. Now I can write my equation in standard form. I'll just start off with my equation from slope intercept form, y equals -1/2 x plus 4. And again, all I'll do is I'll just add 1/2 x to both sides, so I can move my x and y variables to one side, and I end up with 1/2 x plus y equals 4. Now for standard form, one thing that we want to do is we want to make sure that our a and b values, or our x and y coefficients, are whole numbers. All right, so the way that we can do that in this equation is I'm just going to multiply, because I want to get rid of this fraction, right? I want to turn it into a whole number, so I'm actually just going to multiply my entire equation by 2. I'm going to multiply, and you're allowed to multiply the equation by the same number on both sides, right? So if I multiply the left side by 2 and the right side by 2, I can say that 2 times the left side equals 2 times the right side, right? So 2 times the left side, well, 2 times 1/2 x becomes just 2 over 2 x, or just 1x, right? Plus 2y equals 2 times 4, or 8. So this is my equation in standard form, and that's how we can write the equation in all three forms. Okay. Now let's talk about some word problems dealing with linear equations. Remember, one thing just to keep in mind for linear equations and word problems is that if you see a word problem where the rate of change is constant, then it's probably going to be a linear equation that you're dealing with, or a linear situation. If it's like if it's a changing or not constant rate of change, like maybe a percent increase or something like that, then it's probably a different type of equation, like exponential or something. But for constant rate of change, it's going to be linear. So this first problem says the cost of hosting a community dinner is $120 plus $18 for each person attending. Write an equation that gives the total cost as a function of the number of people attending. What is the cost for 65 people? Okay, well, remember how I said that your x-intercept, when it comes to word problems, is like the initial or starting amount, and your slope is the rate of change, right? So we can see that the initial cost is $120, and the rate of change is $18 per person, right? So I mean, if you're calling x the number of people, and you remember that x is your independent variable, right? So it would make sense to say that x is the number of people and y is the total cost, right? Because the total cost depends on the number of people, right? And if we're saying that my slope is $18 per person, $18, I'll write it like this, $18 per one person, right? We can see that that sort of makes sense with the whole change in y over change in x, right? Because every time x increases by one person, y, or the total cost, increases by $18, right? So that's going to be my slope. And I already know that my y-intercept is going to be the initial amount, or $120, right? So I can write my equation in slope-intercept form. I think is going to be the easiest in this case. All right, y equals mx plus b. Slope is 18. Y-intercept is 120. So that's going to be my equation. And now it's asking what is the cost for 65 people. Well, I can just plug in x equals 65. I get y equals 18 times 65 plus 120. And I can just plug that into a calculator. Let's see what that gives me. That's going to give me y equals 12 $1,290 or $1,290 for 65 people. Okay, now let's look at number 2. In 1995, the average price of a home in Summit County was $135,000. By 2002, the average price had increased to $163,000. Write a linear model for the price of a home P in Summit County as a function of the year T. Let T equal 0 correspond to 1995. Okay, so this one, is a little bit more complicated. We can see that in 1995, the average price of a home was $135K. And, in 2002, the average price was $163K. So I'm actually going to write my equation in terms of like thousands. So instead of writing $135,000, I'll write 135. So I can say that in 1995, the price was $135K or $135,000. I'll just write it as 135 so that we don't get confused, right? And then in 2002, the price is $163,000. Okay, so we can see that our independent variable here is going to be, it's saying write a linear model for the price of a home P in Summit County as a function of the year T. So our independent variable is going to be T, or the year, and our dependent variable is going to be P, or the price of a home. And we can see that they're saying let T equal 0 correspond to 1995. In other words, this first statement that we have, when it's 1995, the price is 135, we can say that that corresponds to T equals 0, right? And we can also say that, if T equals 0 when it's 1995, then what must T be equal to when the year's 2000, right? So from 1995 to 2000, 2002, right? From 1995 to 2002 is 7 years, right? So we can see that T must be increased by 7 from 1995 to 2002, right? So I can say that T should be equal to 7, right? If T was equal to 0 at 1995, let me write the numbers here, then it should be equal to 7. If T was equal to 0 when the year was 1995, then it should be equal to 7 when the year is 2002, right? And now I actually have 2 points, right? I have 0, 135, which means that when it's been 0 years since 1995, the cost of the home is 135K. And I also have 7, 163, which means that when it's been 7 years since 1995, or the year 2002, the price of the home is 163K. And from these, I can actually find my slope. I can do 163, change in y, right? 163 minus 135 over 7 minus 0. And let me plug that into the calculator and see what we get. 163 minus 135 is going to be 28 over 7, which is 4. So, there's a couple ways that you can think about this. We can say that 4 is actually the same thing as 4 over 1, right? So we can say that, on average, for every 1 year since 1995, the cost of the home increases by $4,000, right? And now let's say I want to write an equation. Well, in this case, I'm actually, I could write it in 2 ways, right? One way is slope-intercept form, because we actually do have the y-intercept. Remember, the y-intercept is the y value when x equals 0, or in this case, it's the p value when t equals 0, and we do have that point, right? 0, 135. In other words, y-intercept is just the, it's the value of the dependent variable when the independent variable is equal to 0, right? So normally I would write my equation in the form y equals mx plus b. In this case, my independent variable is t and my dependent variable is p, so I could also write it as p is equal to mt plus b. We know that our slope is going to be 4 over 1, or 4, so p equals 4t plus b. And I know that my b value is going to be 135, right? Because when t equals 0, p is equal to 135. So p equals 4t plus 135. And this is the equation for this situation. Remember that this is in thousands of dollars. So, if I plugged in, let's say t equals 2, and I get 4 times 2 plus 135, which is equal to 143. This doesn't mean that the price of a home 2 years after 1995 is 143. It means that the price of the home is $143,000. All right, so just keep that in mind. But this is how we could model this. One more way that we could model this, one other easy way, is using point slope form, right? Y minus y1 equals m times x minus x1. So I have my slope as 4, and I can take either one of these points. I could use the y-intercept if I wanted, or I could use this point. Why don't I use this point? 7, 163 as my x1, y1. Well, if I plug that in, I get y minus 163 equals 4. That's my slope times x minus my x value was 7, so x minus 7. That's another way I could write the equation. And of course, if I wanted to write it in standard form, why don't I do that? Just because I've written in the other forms, right? I can start with my slope-intercept form. I can just subtract 4t from both sides, and I get negative 4t plus p equals 135. That's how I can write it in standard form. Okay, last problem. It says a tomato plant was 8 centimeters tall when it was first planted. Since then, it has grown by approximately 0.75 centimeters per day. Write an equation expressing the plant's height, h, in terms of the number of days, d, since it was planted. I think the easiest way to do this will be using slope-intercept form. We can see that the initial amount is 8 centimeters tall, so that's going to be my y-intercept. And it grows 0.75 centimeters per day, right? So that's going to be my slope. So if I was writing this in the form y equals mx plus b, I'm actually going to change it to h, or height, equals md plus b, where d is the days and h is the height. I can say that h equals 0.75 d plus my y-intercept, which is a. And this is the equation modeling the height of the plant d days after it was planted.